half of section 7.7 is writing and applying exponential functions. Just like with a line, 2 points determine a line, 2 points can also determine an exponential curve. And I'll show you how. We have here, we have 2 points here, the point 110 and 480. What I want you to do is take those 2 points and what I'll do is I'll give you 2 points and I'll say write an exponential function in this form, y equals ab to the x power that passes through these 2 points. And it really actually isn't as difficult as it seems. The first steps are kind of, what am I doing? And you're going to get this. This is so easy. So what you're going to do is this. You've got an x and a y, and you've got an a and a b. So you've got x's and y's here. So if you put in x's and y's, then you have 2 unknowns, right? The a and the b. So first step is to put your 2 points in for the x and the y. So first take your first point, 110, and put that in for the x and the y. So the y is 10. So 10 equals ab to the 1 power. Or just AB. In this case, you can either leave it on or take it off, whichever. And so then your second point is going to be 80 is where the y comes from. 80 equals AB to the x power. The x is the 4. All right, so now we have 2 equations with 2 unknowns, and we know how to solve 2 equations with 2 unknowns. In this case, because we're not adding anything, we can't use substitution, but we can use, we can't use addition, but we can use substitution. So what we're going to do is let's take that little 1 off, and that makes it even easier, but we could do that with an exponent also. In this case, this is just 10 equals a times b. So if we were to solve for a, divide both sides by b, and so a equals 10 divided by b. All right, so what we've done is we've solved for a using this equation. We divided both sides by b. So a equals 10 divided by b. So now we can use that. Do you remember using substitution? We can use this as a puzzle piece and plug it into this equation. So we're going to plug this a, 10 over b, into this equation. So we have 80 equals a, and we're going to plug in the 10 divided by b times b to the 4th, and you can put that over 1 if it makes it easier for you to see the multiplication, because now we can reduce this down, and so 80 equals 10b to the 3rd power. Divide both sides by 10 to get the b by itself. So 8 equals b cubed, and in this case I can see that, well, 2 cubed equals b cubed. Right? I'm just breaking this down into its factors. So 2 cubed is the same as b cubed. So b is 2. You see where I get this? Because the exponents are the same, the bases must be the same. So b equals 2. So if b equals 2, I can simply put b in to this equation back up here and find out what a is. A equals 10 divided by b, and b is 2. So a must be 5. So now I have my a and my b, and now I go back in and put it into the original format that we want. So we want y equals a, which is 5, times b, which is 2, to the x power. Now be careful. This is the end. You have to stop here. You can't multiply this 5 times 2 because the 2 is to the x power and the 5 is not raised to the x power. So don't make that mistake. You can't multiply those two. So your final answer is 5 times 2 raised to the x power. All right? And that's how you do. The bulk of your homework will be these. All right? No problem. The next thing we're going to do is this. If you have a set of, oh, hey, look. I have a thing that says all of this, so I can just read it off. A set of points in the form of xy fits an exponential pattern if and only if the transformed points x, the natural log of y, fit a linear pattern. Let me show you what I mean. All right, so what we've got here is I have, and I'm going to erase this because I'm going to use this upper area. I have, in a real life situation, I might sell some scooters. I I might. You never know. Okay, so if I'm selling scooters, and in the first year I sold 12, and in the second year I sold 16, and so forth, using these numbers, where the top number, the X, is the number, the number of years I've been selling, or the year in which I sold scooters, and the Y, or the bottom number in this case, is the number of scooters I sold in that year. So in the fourth year that I was selling scooters, I sold 36. So what I want to know is this an exponential curve? And if so, what is the formula for that? Well, my statement says that, and this IFF, remember, is if and only if. So it has to be true in order for this to be an exponential pattern. I have to be able to take my points and transform them, or change them to, instead of just x, y, change them into x natural log of y. So what I want you to do is this. I want you to take each of these y terms, and I want you simply to put them into your calculator and change them to natural log of 12. So put in, if you've got a scientific calculator, 12 natural log 12, and put down, and then write that down next to your x. And what I've done in my, just so that you know, I went up and down in my transform so you don't get confused. And then, and I'll show you in just a minute what I mean by that. And then if you have a regular, an iPhone, if you're just using your phone for your calculator, you'd put in 16 and then push the natural log button. Whatever you get there, put it here. All right, so you do that. Please pause and do all 7 of those numbers, and so you get a set of numbers that are x log of y, natural log of y. Make sure you're using that natural log and not the log. All right, go. Did you do it? Don't you come back if you didn't do it yet, because here's what I'm going to do. I'm going to show you. I already did it, and let's see if ours match. All right, so actually I don't think I need to have it up this high. Let's try it this way. All right, so my transformed numbers are this. So in the first year, the natural log of y is 2.48, and so forth. Now what I want you to do is this. I want you to take a piece of graph paper, and I want you to graph each of these points. Because the whole point is, and I'll keep talking while you get your graph paper and you plot those points. Because the whole point is, if these new points fit a linear pattern, if they make a line, or at least a line of best fit, if they have a line that's pretty close to a line, it doesn't have to be exact, but if it's fairly close to a line, then that means that that your points, the original points, represent an exponential graph. All right, so get your graph paper out, plot those points. As soon as you have all of them, then come back. So if you need to pause, go ahead and pause. All right, did you do it? Here we go, because I've already done it. All right, so here's our points. Here's our points. There's the 1, 2.48, 2, 2.77, 3, 3.22, 4, 3.58, 5, 3.91, 6, 4.2, and 7, 4.56. So these are my points that have been transformed. So this is the x stays the same, and the y, I've taken the natural log. And so I can see that, oh yeah, that's pretty darn close to a line. It's not exactly a line, but that's fairly close to a line. So I could have a line of best fit through here. So now what I'm going to do is I want to change this. I'm going to take that information and I want to get an equation out of that. And I want an equation that is an exponential equation. So if you remember, if we use this line of best fit, if you remember, the equation for a line was y minus y1 equals the slope times x minus x1. Remember that? All right. So that's going way back. Oh my goodness. All right, so here's what we're going to do. Now we're going to transform this because we're not using just y. We're using the natural log of y. I'm going to change the natural log of y equals, well, oh, not equals, that's a minus, minus y1. And here's, oops, let me back up. In order for this to work, you just got to pick 2 points, all right? So what I'm going to do is I'm going to pick the first and last points on this line. So this point and this point. So the 1, 2.48, 2.48, and the 7, 4.56. All right? And you can pick any one on there with these, and I think you only have 2 problems like this on your homework. You can do this, just 2. All right, so after you plot your points, pick 2 points that are on that line of best fit to put into this equation. All right, so the reason you have to pick 2 is because you have to find a slope, right? So let's find the slope. And the slope is going to be, remember the slope is the y minus y over x minus x. So that's where you're going to have to take the 4.56 minus 2.48, those are my y's, and subtract them and put that over 7 minus 1. And when I did that, I already did that, so if you want to pause and finish that, so subtract that using your calculator and divide by 6, you should end up with roughly 0.35. And so that's going to be your slope. Do you see where I got that? Okay, so I got that from these 2 points. I used those 2 points to find the slope, the y minus y over the x minus x. Okay, all right, so now what I'm going to do is now we have our parts. I'm going to put that in to this equation. So I'm going to use the y 2.48 equals the slope, which I got from here, 0.35, and then x minus x1 is just 1. All right? Whew! All right, so now at this point, I'm just going to simplify it as far as I can to get my equation. So, oh dear, what did I do? All right, so what we're going to need to do first is this needs to be distributed through. So you're going to have a natural log of y minus 2.48 equals 0.35x minus 0.35. Distribute that through, and now you can combine some like terms. Let's get this 2. Which way do I want to put it? Let's add the 2.48 to both sides. Plus, let's not do this in my head so I don't mess up. Okay, so do you see what I did there? When I added the 2.48 to both sides, it combined the like terms over here. So now what I have is I've got the log all by itself, the natural log. And remember, if you've got a natural log, you can exponentiate that to get rid of that log, which is going to make this a little bit of a mess, but it's okay, we can handle this. So what we're going to do is we're going to exponentiate using the base of this natural log. So now we have just y. And remember, that's the whole point. When we're finding the equation here, we want to know what y equals. So y equals e to the 35x plus 2.13. So now so this is e raised to all of this. Can we simplify this just a little bit to make it so that it's an exponential in an exponential form? What we can do with that is, remember, we can split this up, and this is the same as e, and I'm gonna trade these places also. So e to the 2.13 times e to the 0.35x. Okay, so I just expanded that just a little bit. Remember, if we're adding these exponents, that means we multiplied the bases. Okay, so now if you put that into your calculator, e to the 2.13, remember, is an actual number. It's a constant. So that number is 8.41. And then what we're going to do is we're going to take, this is also e to the 0.35 is also a constant. So plug that into your computer. Push your e button and then 0.35 power. E to the 0.35 power is 1.42. And that's raised to the x power Oh my goodness, what do you think? So now we have an exponential equation for this exponential curve that represents the number of motor scooters sold. Okay? Now, here's the deal. I'm only giving you 2 of these in your homework. I want you to do them both. And now after I've shown you how to do it all by hand, I can also tell you that your graphing calculator will do this. I believe it's called exponential regression. If you put all of these numbers in, it will find your line of best fit and it will come up with an equation like that. So I do want to see your work. I do want to see you do one. If you'd like to check your work by just simply plugging it into your calculator, you certainly may do that. Okay? Because at the end, then what we can do with this information is, if we know this is the equation that represents how many scooters are sold each year, then we can simply put in the number of years that we want, and we can estimate how many scooters we're going to sell in any given year. So if I wanted to know, well, how many scooters are going to be sold in the 8th year, then all I would need to do is plug in for the X, plug in 8 years. And so in your calculator, you would put in 1.42 to the 8th power and take that number times 8.41. Or if you've got a scientific calculator, just plug it in exactly like this, putting in an 8 for the X, and you would find out that in 8 years, you're going to sell roughly 140 scooters. Okay, so you can put that into your calculator and make sure that you got that same number. Whew! So there's a lot there. There's only 2 different types of problems that you're going to be working, but they're pretty tedious. So you don't have a long assignment. You might need a backup or ask me in class. I am more than willing. Let's do a couple of these together if we need to. Okay? See you soon.